this video, we're going to do one final multiplicity practice problem that is similar to a problem that you will see in my lab. In this problem, they're giving me a graph. It says that the graph is a complete graph, that is, it is continuous and displays the function's end behavior. So we don't have to worry that there's some other turns or something flipping around outside of the graph. It's just going to continue rising on the right side and falling on the left side. All zeros are integers. Answer the following questions. First, we're going to list the zeros whose multiplicity is even. So looking at the graph, an even zero would touch and turn around the x-axis at that point. So when I look at this, I see that there are no zeros where the graph is touching and turning around. The graph is crossing at all three zeros. So this would be answer choice B. There are no such zeros. Question 29 says to list the zeros whose multiplicity is odd. So multiplicity is odd means that the graph is crossing the x-axis there. I can use this information to help me identify where those are. So this is telling me the scale of the graph. The x-axis is going from -5 to +5, and each tick mark is worth 1. So I can count here and see that this x-intercept is located at -2. So that's going to be 1 0 with an odd multiplicity. I also have a 0 with odd multiplicity at +1 and another one here at +4. So 1, 2, 3, 4 is where the second or third 0 is. So -2, +1, and +4. And that's going to go with answer choice A. Question 30 says to write an equation expressed as the product of factors of a polynomial that the graph might represent. Use a leading coefficient of 1 or -1 and make the degree of f as small as possible. So we're going to use the information that we collected here to kind of go backwards and write the equation that would lead to this graph. So I'm going to write my equation as y equals, and then I'm going to write these sets of parentheses that would lead to these zeros. So if I have a 0 at -2, then that means one set of parentheses is going to be x plus 2. And I know that there on the graph is crossing the x-axis. And I can see that it's going straight through. It doesn't have that little wiggle or flattening out part. If it had the flattening out part and was still going through, then it would have degree of 3. Since it's going straight through, that means it has a degree of 1. So I could put a power of 1 on this set of parentheses, or I don't need to. Then I have an x-intercept at +1. So my factor that would make that x-intercept at +1 would be x minus 1. And again, the graph is going straight through there, so it has to have an odd power on it, and since it doesn't have a flattening out part, I can use a power of 1. Same thing at +4. That factor is going to be x minus 4, and it's going straight through with no flattening out part, so it has a power of 1. Finally, looking at what the leading coefficient should be. My end behavior tells me that. So since my end behavior here is that it is falling on the left and rising on the right with an overall positive slope, I would have a leading coefficient of +1. I don't need to add it here, but I can. If it were the other way around, so if it were an overall downward graph, rising on the left and falling on the right, then I would put a -1. So now we're going to graph our function to check that it is correct and identify the y-intercept. So on my Desmos graphing calculator, I'm going to type in my factors, which are x plus 2, x minus 1, and x minus 4. So here's my graph. And overall, it looks like it does match the graph in my picture, although my scale is a little bit different, so that's why it looks a little bit more stretched out. If I wanted to, I could use the window button to set the scale to match. So to do that, I'm going from -5 to 5 and -12 to 12 on the y-axis. So I can change those here. Then it looks a little bit more like my graph in the picture. But what I really want to check is the x-intercepts and make sure that they are at the same points that my picture shows where they are supposed to be. Then finally, I want to identify the y-intercept. On this graph, it's possible that I could count using the tick marks here. So it looks like it's at 1, 2, 3, 4, 5, 6, 7, 8. But if I click on my Desmos graph, it will tell it to me very easily that the y-intercept is at 8.